Yeah, obviously we need a way to control the T-Rex. So if we take a look at our class diagram here, we said that there will be an input controller that actually processes the controls in order to make the T-Rex do whatever we want the T-Rex to do. And I think we need to make some small adjustments. First of all, we removed the Sprite property from the T-Rex because it now uses an animation. So let's remove that here. And also, well, basically, if we take a look at the game, in the game, we have the ability to jump as high as we want. Basically, so the longer we hold, the longer we hold the arrow key, the higher we jump. And if we release it early, we basically cancel the jump. So I think it would be better actually here to not have a jump method, but to basically split this into start jump and continue jump or something like that. So that when the arrow key is first pressed, the jump will start, and then if the arrow key is hold, the jump will be continued, and if we release it, then obviously the T-Rex will start falling to the ground. So let's actually rename this start jump. And continue jump. Something like this, but yeah. I just want to make sure that this class diagram is still up to date and correct, because I may attach it to the source code for this tutorial, so that yeah, people who watch the tutorial, watch the video, can always reference this diagram. Yeah, so let's go back into the code and let's see. First of all, we need our InputController class. So let's go ahead and let's maybe create a new folder, namespace. Yeah. Create a new folder, name it, I don't know, system. It doesn't really matter. Cool. Folder name system, and add a new class here and call it InputController. There we go. I'm going to go ahead and make it public, even though it's not that important. So now let's take a look, reference our diagram here. In the InputController, we basically just said it needs to have a field of type T-Rex and a method named processControls that takes the game time as an argument. So let's go ahead and do that first. Private T-Rex, and T-Rex is in a different namespace since we just put this in the system namespace. So we have to add a using directive here, using, what do I do? Something's fishy. Okay, sorry. Using T-Rex runner entities. Sorry about that. There we go. T-Rex. And we will need a constructor so that we can initialize the InputController properly and actually assign an instance of T-Rex. So ctor, double tap, and add a parameter of type T-Rex, call it T-Rex, and then here assign the field. There we go. And now we need a method that doesn't return anything, so it's void, and it's called processControls. and it takes an instance of game time, which again is in a different namespace from the MonoGame framework. I will simply use IntelliSense to add the using directive using Microsoft XNA framework. There we go. Yeah, so first of all, yeah, in our Trex class, let's go back into the Trex class real quick. Let's actually create a first stub for the begin jump method, because I think that's the first action that we want to implement. Public bool begin jump, and we can only start jumping if we're not already jumping, if we're not in midair. So let's check here if state equals jumping, or state equals falling, return false. Then we will simply do nothing and just return false to indicate that the action failed. And otherwise, I will for now simply return true and do nothing. And in the constructor, let's pass a sound effect, which is also in a different namespace. So I will have to add a using directive. There we go. And call it jump sound. There we go. And let's declare a new field of type sound effect and name it jump sound as well, with an underscore as a prefix. There we go. And then initialize that field in the constructor. We can do it up here. Jump sound equals jump sound. There we go. And what we want to do for now in the begin jump method is simply play that sound by calling its play method. It's as easy as that. Yeah. So let's go back into the controller, in the input controller. Go there and now say, first of all, let me think. There is a class in the MonoGame framework that is called KeyboardState. Now, I don't remember off the top of my head what namespace it is in, but I will let IntelliSense take care of that. And it's obviously in Microsoft XNA framework input. There we go. And it will give us the current state, as the name suggests, of the keyboard. And with that, let me see. Yep. There, I can use the keyboard class. It has a static method called GetState, and it will return the state of the keyboard as a KeyboardState instance. And now I can check with that. I can check if the if a certain key is down. So isKeyDown is a method that I can pass in a key here, which should be the up arrow. I think it's just called up. Yeah. So this returns true or false. Is key down, keys up. If this is true, then do something. Something like this. But now this will return true for the entire time that the key is held down. So if I left it like this and just held down the up arrow key, it will constantly call this begin jump method and play the sound. So obviously that's not right. So let's see. first of all, we don't want to be able to hold down the key to start jumping, right? It should only the moment I press down the key, we should check if the T-Rex is currently able to jump, and if yes, then start the jump. What we can do is have a field here, private KeyboardState, and call it previous keyboard state, and it will store the keyboard state as it was in the previous frame. So hold on. And keyboard state is actually a struct, so upon assignment it is copied field wise. So this field doesn't after I assign this field doesn't reference the same instance of keyboard state. Instead, it will reference a new keyboard state object that is an exact copy of this keyboard state object. So yeah, get the keyboard state, and here we can check if. Let me just write the code first. Like this. So if in the previous keyboard state the key is not down, and in the current keyboard state it is down, so if it has just currently been hit, the key, then we want to begin jump, but only if we are not already jumping. If we're already jumping, we want to instead call the continue jump method. It doesn't exist yet, so let's create a stub for now that does nothing. And it just simply returns true. So here we can check Trex state does not equal jumping, then begin jump, else if it's not jumping, we will start jumping unless it's not possible, which is covered here. And otherwise we will continue jumping unless it's not possible, which will be covered in the logic of this method. So that should be fine. So for now, the only thing begin jump will do is play a sound effect, but this will indicate to us obviously if it works. So let's try this. Let's go into our Trex runner. Where is it? Let's go into our game class. Where is it? Trex runner game here. And now this here the compiler indicates an error. That's because we need to pass the sound effect here, which would be SFX button press. And that should do. But then also, obviously, in our update method, we have to call the process controls method of our input controller. So here, say, oh, first we need to create an instance, obviously, of the input controller. So in the, first of all, create a new field, private input controller, InputController, which is in a different namespace. So there we go. Here, and then in our load content method here, after we created the Trex, we will also create an instance of the input controller and pass the Trex that we just instantiated to the constructor. There we go. That should be fine. And then on our update here, we can say input controller process controls and pass the game time. There we go. Let's play and press the up arrow, and it actually plays the sound. And if I hold it down, nothing happens. It plays it once, but it doesn't repeatedly play it. So yeah, it works. It doesn't actually jump, obviously, because there's no logic behind this, but it does actually call the correct method and play the sound. Okay, so I just went ahead and watched the recording footage so far, and turned out that for some reason it wasn't recording my desktop audio. And I think I fixed it now, so let's open up the game again and hit the jump button, aka the up arrow key, a couple times. So you can see that it actually works. It's playing our sound effect. And yeah, let's see what we can implement next. Okay, actually, what I want to do is optimize something here, because I find it a little bit, not ideal that in our Trex class we actually create a new sprite animation over and over. It kind of produces a lot of garbage, and also I think it's not necessary. What we can do instead, let us go back into the sprite animation class. I can just right click here and say go to definition. And then what I want to do is add a method that I will call clear. And what it will do, it will remove all of the frames by simply calling the clear method of the list containing the frames. And if you, after clearing, the animation should also stop automatically. Let's actually make it stop first and then clear the frames, even though it doesn't really matter. Now let's go back into the Trex class, and instead of creating a new sprite animation over and over, let's actually, in our constructor here, create an empty animation. And then in our create blink animation method, we will, instead of creating a new one, we will here just set up the animation, set up the frames of the animation, but not actually create a new instance. So here we can just call the clear method, which will remove all of the frames from the animation. Then we set it to should loop false, that's correct, and then we add the frames. That seems to be all right. Now here, yeah, I think that'll do. Yeah, I think that's the only change that I really wanted to make here. Let's test if this still runs. And yes, it still blinks. I think this is a little bit cleaner to actually create an instance in the constructor and then work with that instance. Instead of recreating new instances all of the time over and over. It kind of produces a lot of garbage on the heap. So yeah. So now that this is taken care of, let's take a look at what we can do next. And yeah, we said that we wanted to actually implement this begin jump method, and of course the continue jump method as well. So first thing we want to do here is, after playing the sound, we want to set the state to jumping to indicate that obviously now the Trex is in a jumping state. And okay, let's see. What we also need to do is change the sprite of that is rendered, sprite of the Trex that is rendered to the jumping one. So let me just open up the sprite sheet here again. And the jumping one, I think, ooh, which one is the jumping one? Is there actually a sprite that is rendered explicitly when it's jumping, or is it just the running sprite? And it is actually the idle sprite, so we can just reuse that. So we don't actually need to define a new sprite for that. So okay. So that means let's take a look at our draw method. Yeah, so that means here, let's say else if state equals jumping or state equals falling. And then what we want to do is draw the idle sprite. At the current position. So that's fine. Now, obviously now we need to change the vertical velocity of the Trex. When we jump here, we obviously need to move the Trex on the vertical axis. So let's see. Let's define a start velocity for the jump as a constant. So here private constant float jump start velocity. And it's going to be in pixels per second. So let's say, since we're moving up and not down, it has to be a negative value. Because remember, the coordinates go from the upper left corner to the lower right corner. So let's say minus, I don't know, 30 maybe. Let's try that. Let's play around with this value a little bit until we find an appropriate one. So let's create a new field that stores the jump velocity. Or no, let's call it vertical velocity. And then when we start jumping, we want to set the vertical velocity to this constant value, jump start velocity. And now, let's see what else. In our update method, we need to update the position. So let's here add an else if state equals jumping. Then what we want to do is update the position. Actually, when it's falling too. Something like this. And then update the position. Remember, we have a position property. And we can set it like this. And yeah, we could just do this, but this would mean we would increase the y component of the position by the vertical velocity value each frame. So basically this would mean 30 units per frame, but we don't want to do it per frame, but instead we want to be frame independent. And actually we want to the speed to be 30 pixels per second. So what we can do here is we can use the game-time object to get the total number of seconds that have passed between frames. And since this is a double, we have to, here, this total seconds property is a double, we have to cast it to a float. And that'll be all right. And now we're frame rate independent because we scale the velocity value by the actual time value, the number of seconds that have passed. So now we're basically increasing the position by or actually we're lowering it because this is a negative value by 30 pixels per second. So let's try this. Now it would actually move indefinitely. Yeah, right. So now it just starts floating until it's off screen. Okay, that's all right. It was quite slow, so let's actually increase the value here. Let's say 60. And hit the jump button again. Still quite slow. So let's say maybe 120. It's still a little slow. So let's say maybe 200 pixels per second. Yes, seems about right. Start again here. Yeah, kinda. We can play with this value a little. For now, let's keep it at 200, minus 200. And now let's see what else. We need to make sure that as soon as it starts jumping, we need to apply gravity so that the velocity slowly decreases. Let's define a constant value for the gravity. Oh. And that'll be, I don't know, 20. And now in the update method, we could say if it's in jumping or falling state, we need to permanently, continuously, decrease this value by the gravity multiplied by total number of seconds that have passed between frames. So that would mean that the velocity would decrease by 20 pixels per second. So let's test this. So now if we wait a little, the T-Rex should start falling. Or maybe not. Let's take another look here. We decrease the velocity by the gravity. So basically 20 pixels per second. See what happens if we increase this value a little. Let's say 100. Oh, of course. We don't need to. Hold on, let me change it back to 20. Obviously, we don't need to decrease the velocity. We need to increase it because a positive value would mean that it moves down on the y-axis. So let's see, where is it? Here. Increase it instead, and let's play. Now if we wait a little, we should see the T-Rex falling down. Or maybe not. Oh yeah, there it is. Okay. So, but 20 is obviously not enough. Let's say, I don't know, 80 pixels per second. Yeah, still a little more, maybe 180. Whoops. Looking good. But it could probably be a little more. Let's say 280. Let's take a look at the actual game and see how fast the T-Rex falls there. It's quite fast. So let's increase this value even more. Let's say 360. Still not enough. Maybe 480. Well, first of all, let's store the start position, at least the y component of it, in a field. So in the constructor here, I'm going to store the start position. Whoops. Like this. And then in our update method, we can here say, okay, decrease the velocity, update the position, or increase the velocity. And as soon as the position is greater than or equal to the start position here, we will actually, let's add some braces. Set the position like this, and then say vertical velocity equals 0 and state, whoops, will be back to idle. Later we should probably change that to running. So what I did here is I check if the position is back to the starting position or even greater than it, so that basically we bounce back on the floor. And let me check. Yeah, so now we can jump repeatedly. Okay, looks good. Okay, so I made a quick cut here and played around with these two constant values to spare you of the boredom of me fiddling with the gravity and the jump velocity. And I just decided for these two values, so the gravity will be 1600 and the jump start velocity will be negative 480. And this and with these values, the jump looks like this. And it comes really close to the original. But now what we still need to do is be able to cancel the jump. So now it right now it always jumps as high as it can until it starts falling. And I figured that maybe instead of having a continue jump method, it would be a little smarter to just have a stop jump, cancel jump, end jump method. So that when we press the jump button, the begin jump method will be called, and as soon as we release the button, the stop jump method will be called, or cancel jump, something like this. Let's rename this, and I'm going to name it cancel jump. And you can only cancel the jump if this current state of the Trex is jumping. So let's say if it's not equal to jumping, then we will return false. Okay, and then we will set the current state to falling. And we will set the vertical velocity to 0, which would basically make it halt in midair, but since there's gravity, the gravity would still be applied, so it would start falling. Okay. So let's go back into our InputController class, and here let's actually change this. So here we're checking if in the previous frame the key was not pressed, the up key, and now it is. That means we started pressing it. Then we check if we're not jumping and begin jump. So let's here say else if previous keyboard state is KeyDown. Oops, keys up. So if previously it was pressed and now it's no longer pressed, and the Trex is in jumping state, then we will call the cancel jump method. Right? Yeah, seems about right. Let me test this. Yeah, that works. It seems a little abrupt. We never change into falling state naturally, basically. So we only change into falling state if we cancel the jump, but it doesn't change into falling state just by having the gravity applied to it. So let's see. Apply the gravity here. And here we can check if state equals jumping and vertical velocity Well, actually, we can make it simpler. Vertical velocity, no. If vertical velocity is greater than or equal to 0, we will put it in a falling state. So first we check if it's in jumping or falling state. Then we apply the gravity, which will change the vertical velocity. And if after applying that gravity, the velocity becomes positive or 0, we will change the state to falling. So now we should no longer be able to cancel the jump while we're falling. Yeah, that seems about right. Really abruptly starts falling, and I don't really like that. So maybe instead of setting the velocity to 0, maybe we should change it to some predefined value. Let's say let's create a constant here. Whoops. And call it cancel jump velocity. And so we want to smoothly transition into falling. That means maybe we can set it to maybe minus 60, maybe. Yeah, let's start with that and then play with that value. And here we can say, instead of directly setting to 0, we will check if the vertical velocity is larger than this predefined value. Then we will set it to that value. Otherwise, we'll set it to 0. Is that correct? So let's say the vertical velocity is minus 200. So then we check minus 200 greater than minus 60, which is false. Oh, we need to do it the other way around. Yep. So if the vertical velocity, let's say it's minus 200, is less than the cancel jump velocity, which is minus 60, which would be true, we will set it to minus 60. If it's already lower than the cancel jump velocity, minus 60, then we will set it to 0. That seems about right. Let's check. Yeah, it seems less abrupt. Let's actually play with that value a little. Instead of 60, maybe set it to 100. Yeah, seems about right. But what I noticed here is that I can jump really, really short. Like, we should specify a minimum jump height. It shouldn't be possible to jump to jump this low. It doesn't really make sense in this game. So let's define a minimum jump height. So let's define another constant. And let's say in pixels, 40 pixels. And then here we cannot cancel jump. So if it's not in jumping state, or if the current Y position minus the start Y position is lower than the minimum jump height. I might have switched. Maybe I have to change these. Let's see. Yeah, it has to be the other way around. So remember, we stored the start position, the start y position in the constructor, and then we simply subtract the current y position and check if it's lower than the minimum jump height. And if that is the case, then we haven't jumped high enough yet, and we cannot cancel the jump, and therefore we will return false. Let's see if that is correct. Yes, it is correct, but it becomes sort of cumbersome and really weird. I can cancel the jump, so if I jump higher than the minimum height and then release, I can actually cancel the jump. But if I release before I have reached the minimum height, it'll just keep jumping. And that is because we only call this cancel jump method in the frame where I release the button, and not after that. So here, if I release the button, we try to cancel the jump, but it may not be possible because I haven't reached the minimum height yet, and after that we will not try to cancel it again. So maybe instead here, let's make it simpler here. If the current state of the Trex is jumping and the up key is not pressed, then we want to cancel the jump. If it's not pressed, I forgot the exclamation point here, the negation operator. Yep, that's much less weird. Yeah, seems okay.